point. So you can see this is another zero crossing point. This is one, this is another, this is one, this is one, this is one, this is one, and this is one zero crossing point. So whenever the signal crosses over this zero line, that's what we call it as zero crossing. And in terms of the discrete signal, that's how we represent. If two samples are, if the sign of the x of t doesn't match with sign of x of t plus 1, then we say there is a zero crossing between these two samples. So let's look at this speech signal, and then what we are plotting here is the zero crossings here. So you should remember that whenever I am plotting a point here, that means I have used an analysis window in this region and then got this point. So to get this point, I would have used a analysis window here and then obtained a value here. So again, we are going to see the voice sections of this signal and the unvoiced sections here. And it's interesting to observe that whenever there is a voiced region, then the zero crossings are very low, and whenever there is unvoiced here and here, the zero crossings are high. So it tells you that the voiced section and unvoiced section can be detected using zero crossings. So it also acts as one more meaningful feature to do the detection of voiced and unvoiced. So typically, if you find the zero crossing in the analysis window to be high over a threshold or something, then the implication is that that analysis window contains unvoiced speech, and if the zero crossing rate is low, then the analysis window is voiced. That means it belongs to one of these classes here. So you can use this zero crossings to detect voiced and unvoiced sections of the speech, and then silence and non-silence parts of the speech. Let's move to our next feature sorry, which is pitch. So we did define pitch in our speech production, but let me do it here again. So pitch is the cycle period, or one cycle period of vibration of the vocal folds. So you should remember that vocal folds are the one which produces, or which are responsible for voiced segments, because they vibrate when you produce the voiced sounds. So pitch is also referred to as fundamental frequency, or F0. This is purely a term here, so there is no great significance, but you should remember that whenever somebody talks about fundamental frequency or F0, then they are talking about the pitch here. So how do you observe, or how do you measure the pitch in the speech signal? So pitch is measured as the time difference between two major peaks in the speech signal. Specifically, the measurement of pitch applies to voiced regions, because that's the only place where that feature is available. For unvoiced regions, most of the time there is no pitch value in the unvoiced regions, so you assign a random value or uniform random value in unvoiced region. So why we are excited about this pitch? So now there is a speech signal, and then at the bottom you are seeing a pitch contour. So again you are seeing the points here, so that means there is an analysis window over here, and then I would have got the pitch value which is plotted here, and then it's connected by a line to depict a kind of contour. So when you get these contours or plot the pitch over a period of time, that's called pitch contours, and also referred to as intonation sometimes. So what is the significance of this intonation contours? So you can have patterns in these contours. So if this is a speech signal, and then if you're finding this falling pattern, this is called fall pattern of F0, then it means that it's a kind of passive sentence. For example, if you're saying she's lying, then your F0 will decrease as you come to the end of the sentence. So let's take another example where you're finding a rise in the intonation here at the end of the sentence. So the rising pattern mostly applicable to interrogative sentences. For example, if you're saying is she lying, so there is a rise in your pitch, and that's what is depicted by these rising patterns. So intonation plays a major role in knowing in the style in which you are speaking, the type of the sentence and emotion, etc. So the other useful thing what you can do with the pitch, you can use this information for gender identification. So it is known that male speakers have a pitch in the range of 50 to 200 Hertz, whereas female speakers will have the pitch in the range of 200 to 450 Hertz. So if you get a speech sentence, or if you get a speech signal, and then if you extract pitch over multiple analysis window, then you observe the average pitch is somewhere between this range, then you can clearly say it's a male. If it is not, then you can clearly say it is female. If it is more than this specified range, then you can even make assumption that particular signal may not be speech at all. It can be some music or some audio or something. So the information or the pitch contour plays a major role in producing the naturalness of the synthesized voice in the context of text-to-speech systems, and it's also useful for emotion and expressive speech synthesis. So there is one more technical term you need to know here, that's called prosody. So prosody is a term used to denote a set of features which produce naturalness in the speech. So first one is pauses. So when you're saying a sentence, for example, speak this sentence. So after, for example, you have a small pause here that increases, or that shows that, for example, is one phrase, and then speak this sentence is another phrase. So these short pauses are essential for or play a major role in conversational speech as well as in natural speech. And the second constituent of prosody is pitch, which is also referred to as intonation. And then we did see the patterns the pitch can take for different type of sentences, the fall and rise patterns, which we saw in the last slides. The third one is duration. So if you're speaking fast or speaking slow, the durations of the phones change. So that's also constitutes as a part of the prosody. The fourth one is loudness, or relative energy or volume. So if you're emphasizing, or if you want to emphasize a particular word or particular topic, you speak with high energy. So that's called as loudness. So all of these four features constitute what we call as prosody in the speech. So what you should note in this lecture is what are the representations of speech signal, and I mean, why do we extract features from the speech signal, and how to extract the features. And specifically I want you to make the note of the short analysis window which we use in processing the speech. So the speech is typically broken or analyzed over shorter analysis window, and then the features are extracted over the shorter analysis window. The third thing is the energy and the zero crossings and their usefulness, pitch and its contour, and the prosody part of it. So you can go through the additional readings which are mentioned here. Then if you have any doubts, you can send me an email. Thank you.